So this is the last video regarding the summer exam. So I've kind of put all the graphs here together just to, I suppose, go through it a little bit quicker. So it says the graph below shows a graph of the output of an alternating current AC voltage source. So we were given the, I suppose, the bold black line there. And the first question was write down the equation of the midway line of the wave. Now, so all we were looking for was literally where the midway line was. So this is obviously a 3. And down here, the lowest it goes is -3. So we can very, I suppose, hopefully easily see that the midway line, I'll do it here in another color. The midway line is 0, basically. 5 marks in the exam. The next question was write down the maximum output voltage. Well, the maximum, so the highest that the graph ever reaches is 3. So we can see that here, we can see that here, and because it's cyclical, it'll just continue getting as high as 3. So what I've written is 3 volts, and that was worth 5 marks. So they were, I think, pretty straightforward questions in the test. At least I hope so. Then it said, hence or otherwise, write down the function that represents the output voltage. Now, what we had to do here was, like we practiced in class, putting together the actual function. So a good starting point, I think, is always to start with, well, is it sine, cos, or tan? So with these graphs, we generally dealt with sine or cos. Now, I have picked cos. Why did I pick cos? Well, again, we're only talking about the bold one at the moment, the thicker black line. So it all comes back to the idea of the unit circle. So if in doubt, go back to your unit circle. This, remember, is 1, 0. This is 0, 1, 0, minus 1, 0. This is minus 1, 0. And down here we have 0, minus 1. Now, remember, Christian name, surname, Christian name, surname. So the first part is your cos. So we end up with 1, 0, minus 1, 0, 1. Now, if you think about that pattern, so that's starting at 1, down to 0, down to -1, back to 0, back to 1. So if we were to do a quick sketch of that, just a regular cos graph, not this one, but just a regular one, we start at 1, we go to 0, we go to -1, back to 0, up to 1. So cos graphs have that kind of a shape. Sorry, that's quite badly drawn, but hopefully we get the concept. So cos graphs start up, basically. They start on the up. Whereas a sine graph, I mean, if you have a quick look at sine there, it's 0, 1, 0, -1, 0. So cos graphs start there. They start at the origin. This clearly does not start at the origin. Now, I know that it's 3 instead of 1, but the shape, we're just talking about the shape is cos. So that explains why I picked cos. Now, why did I pick 3? Well, the amplitude is 3. So the reason I picked 3 was because we talked about this in class, the amplitude. So from the midway line, basically, to the highest is 3. So that is why I have put 3 there. It's positive 3 because the cos graph is as we expect it to be, as opposed to upside down. Like, I mean, it is possible that you begin down at -3 and go the other way. That would be a negative cos graph. So anyway, we don't have to worry about that. In this case, it's positive. Okay. Now, where did I get this 25 pi? Well, the 25 pi comes from this, basically. Now, what is this? Well, we know, well, I hope we know that cos graphs are normally, when we talk about their range, they're normally 2 pi. Now, I have divided that by 0.08. So 0.08 is a full period. Like if you look at this here, do you see the way that is what we call a period? Because after that, the pattern continues. So where I have the blue highlighter, that is 1 period. So 1 period brings us to 0.08. So what I'm really doing is I'm dividing what the normal period would be with the period in this particular example. So the normal period of cos divided by the period in this example. And that's where I'm getting the 25 pi. So I'm just going to pop that into the calculator again. 2 pi over 0.08. So that gives me my 25 pi. So that's accounted for. T is simply because in this particular case, we're talking about time. It is, I suppose, the unit really is all it is. It's the unit. Okay, and that was worth 10 marks because there was a bit more work in that. So your amplitude, your shape, your period, and then the unit being time. Then it says a second AC voltage source is connected where its output is given by 1.5 cos 50 pi t. Draw the graph of the output on the graph above. So what we're doing now is we need to draw that on the graph above. Now I've already drawn it, but just to explain. So I'm going to start by zoning in on 0.5. So that is your amplitude. So you'll notice here when I go to draw it, so this is the hand-drawn one. Do you see the way I've come in here at where I think this 1.5 is? So there. And that is why I've started the graph there. Okay, so you'll see there where I have the blue arrow. That is why I started the graph there, because to me that looks like 0.5, more or less. Okay, then it says cos. So the good news here is the shape is the same. So if you look at the hand-drawn one I did, notice it's the same. It starts up, it hits the axis, below, back to the axis, back to up. Now, the shape is the same, so it's still a cos, but you can see the period has shrunk. Like the period is now there, isn't it? But how did I know that? Well, that's where I'm explaining the rest of it. So 0.5 is the amplitude. So we go 1.5, I should say. So 1.5 above 0. The cos is the shape. Now, the 50 pi, let me explain. So I've explained that here, actually. So what I've done is I've put the normal period for cos, 2 pi, over the mystery number because I don't know, you know, before I drew that, I didn't know what the period was going to be. And I let that equal to what it says it is in the question, the 50 pi. So by doing that, I can discover this mystery number and I cross multiplied. So I multiplied this guy by the 1 and x by the 50 pi x, got x on its own. And that is where I got the 0.04. So just to clarify, I obviously had this drawn already in the solutions, but I didn't know that. The last thing I did here is what I'm trying to say is I drew the graph last. So I marked off the amplitude first. I knew the shape was going to be the same, but I did need to find out what the new period was going to be. And I did that by the calculation here. Now, how did I know where the other bits and bobs went? Well, I've had to follow the shape. So the shape of the cos graph is always up axis down. And I knew the down, actually that doesn't look great there, but the down is also negative 1.5. That looks a little bit dodgy there, but sorry, that doesn't look ideal, but I'm just looking back on it now. I mean, obviously I just did this for the marking scheme, but yeah, so I knew I started up axis down, back to axis up, and I knew the up had to be at the 0.04. So that's how I knew. And then I repeat that pattern because this period is obviously shorter than the other. Okay, so that was that question, and that was worth 10 as well, I think, wasn't it? Yeah, I gave that 10 marks there as well. Okay, the next question. So I've taken a shortcut here because otherwise the video will be too long for YouTube. So you're given all this detail about people taking the Leaving Cert. So people who were born, people who took the Leaving Cert, and people who went to college. So there was kind of, I suppose, what I would call 3 sections. So maybe if we highlight them. So these were just the people who were born. They didn't do anything. They just were born. Then the middle group are those who sat the Leaving Cert. And then the final group were the people who started college. So we don't really know yet if there's any connections here or anything, but that's just the structure of the table. Now, we had to represent the number of males and female candidates and the total number of candidates who completed the Leaving Cert. So we are only talking about the yellow section. No other section is relevant. We haven't been told to graph the births. We haven't been told to graph anything about college. It is purely the candidates for the Lebenscert, so the yellow section. So how do we do that? Well, let's think the axes first. Number of students, and I'm going to do it in thousands. And we are told that we can round to the nearest thousand. So, for example, if we go up to the very first figure, males, I'm going to round that to 16,000. Why? Because obviously when I'm rounding, 16,381 is closer to 16,000 than it is to 17,000. So that's what I did there. I rounded it to 16,000, and it's, again, not amazing, but to see the way I have 16 there. So to the best of my ability, it's not going to be perfect. Did the same for the females. That should be around 19,000. So I've done my females. You'll just see just below the 20. And then my total is here. Well, the total is given actually, isn't it? Yeah. So the total is about 36,000. So just slightly, just barely above, just barely above the 35,000. So I have 3 columns. I have the date on the bottom, 1973, and then a gap. Okay. And the thing about the bar chart, bar chart. So there's the word bar chart. You have to have the gap. The gap is as significant as the bars. If you didn't put the gap in, it's not a bar chart. You've made it into a histogram when it shouldn't be. And then you'll notice there, you can pause the video if you want and check it against the table. So if I do it there, you could pause that if you wanted to and go back and check the other figures. But that's the idea. So if you can do the first bit, obviously the rest you just copy. So you put your date, males, females, total. Some of you I know put the total on top, but you see the total has to reflect everybody. So some of you stacked them, but then you couldn't read what the actual female was. So yeah, there was a bit of an issue there with some of yours for that reason. Actually, I'm going to cut the video here because it'll be too long otherwise, and I'll continue it in the next.